CloudDB, shaping your new normal.
Hello, everybody from the APAC Oracle User Group community. It's my pleasure to be with you today. I'm the product manager for Zero Downtime Migration and the ACFS cluster file system. My name is Ricardo Gonzalez. I work for the Oracle Maximum Availability Architecture team. We oversee everything that has to do with high availability, scalability for your database. So Oracle RAC, Clusterware, ASM, ACFS, DataGuard, you name it. I oversee cloud migration, so I'm going to be talking today to you about how you can use ZDM, our product or engine for migrating databases to the cloud, and also perform an in-flight upgrade. So stick around. It's my pleasure again to be here with you, and thank you so much for joining me. So here we have today's agenda. I'm going to be talking about the product, Zero Downtime Migration. I'm going to make a brief introduction to how the product works, how it was designed, and different features and functionality. I'm also going to talk about the architecture for logical migration, because that's the one we're going to be using today, and explain how it would work step by step. Then I'm going to actually go and talk, which is point number 2, on how a step-by-step migration would work with an in-flight upgrade. In order to do so, we will cover the different prerequisites for the source database, the target database, connectivity, SSH keys, the object store, backup location, the installation of ZDM, the configuration of a Golden Gate hub, etc. And then we will, I'll show you how it actually works. So I'll show you how the migration command works, which parameters are needed, and then give you an example of how that migration will end up being. Finally, I'm gonna share some resources with you, some links and information for where you can get more info regarding ZDM, the product, and also where you can download it, etc. So let's get started. So let's first talk about the Zero Downtime Migration. The product itself is the main engine and main solution for Oracle Cloud Migration. The product was born in 2019, but has been in the work for a long time. And the idea of it is to be simple, to provide a simple framework for your cloud migration, to leverage the Oracle Maximum Availability Architecture best practices, to provide a secure, safe, and with zero data loss way of migrating your databases to the Oracle Cloud, and of course for it to be free. So even though we use different products associated to it, the use of ZDM is free and has no cost. For instance, when we use Golden Gate, there is a specific license for an image in the Oracle Cloud Marketplace for this Golden Gate hub that we will be using, that specifies that the use is free for around 108 days. But of course, please go and check the license specifically for the terms of use. But as you see, we are enabling you to migrate your database to the Oracle Cloud in a free fashion. As I mentioned, ZDM is the main engine behind Oracle Cloud database migration efforts, and it also powers other products. So for instance, there is a service native to Oracle Cloud Infrastructure, OCI, and the service is called DMS, or Database Migration Service. This service uses ZDM, or Zero Downtime Migration, under the covers. So the product, as you can see, is quite comprehensive. It's been ongoing and developed and launched 3 years ago. We recently launched a new version called 21.2, and we're really happy to share this with you today. So let's talk more about it and how it works and what's underneath ZDM. So the latest release of ZDM is ZDM 21.2, came this year in August, and it's great and has many features and functionality. Let me start with the basics. First, for source databases, ZDM supports Oracle databases, both Standard Edition and Enterprise Edition, from 11.204 version onwards, so meaning higher versions such as 12, 19, etc. Also, we support Oracle databases running on AWS RDS that can be migrated then to Oracle Cloud. As targets, Oracle Zero Downtime Migration supports database cloud services virtual machines. It supports Exadata Cloud Services, Exadata Cloud Customer, Exadata On-Premises, autonomous transaction processing, and autonomous data warehouse. Also, for supported source platforms, ZDM supports Oracle databases that are running on Linux, on AIX, and on Oracle Solaris. Now, we support conversion from non-CDB to CDB databases during the migration process. We support two types of migration workflows, one physical migration and the other one logical migration. We also support in-flight upgrade, meaning you're migrating from one source level of a database, meaning a database, for instance, 11G, to a higher target version, meaning 19C. This is only achievable on the logical migration workflow. So I will be talking about today about that and how we can work that way. Also, we use different migration methodologies. So for physical migration, we use RMAN, the recovery manager, and we use DataGuard. For logical migration, we use Data Pump and Golden Gate. So today, in my example, and our walkthrough of a step-by-step how you can achieve this migration and upgrade, I'm going to be talking to you and explaining to you how we use Data Pump and Golden Gate. Let's start now with the step-by-step migration. I'm going to do so by starting with the architecture of the logical migration workflow that we're going to be using. So we're going to talk about all the different components and how it would work on a step-by-step basis, and then work our way through each one of the prerequisites and actual migration process. So here we have the architecture for online logical migration with zero downtime migration. We have on the bottom a ZDM service or server node where ZDM is installed. This server is running on an Oracle Linux 7 OS, and it can be deployed anywhere. You can install this on a virtual machine in Oracle Cloud Infrastructure, or you can set up a VM on your source database server, or set up a VM on your target database server. That's all fine. We just require for it to be running on Oracle Linux 7. Then on the left side, we have the on-premises source database. In this case of the migration, I'm going to be making an example of an 11.204 database that we will be migrating. Then we have connectivity between that database and the backup location, and also the target database cloud service, which could be many things. It could be database cloud service, it could be Exadata cloud service, it could be the autonomous database as well. Then we have the Golden Gate Hub on top, which is running on an Oracle Cloud Infrastructure compute node. And this Golden Gate Hub, or GG Hub, has two microservices for Golden Gate. One acting as an extract, which will capture transactions from the source database, and one acting as a replicate, which feeds out of the extract and synchronizes and applies the operations on the target database. So provides the synchronization mechanism for ZDM to perform an online migration. So today I'm gonna walk you through all the different components. We're gonna start with the source database, how it, what are the requirements. Also, we're gonna talk about the target database, what are the requirements for it, the thing that you need to consider. The ZDM service node, what are the different requirements and how to install it. Also, the backup location, SSH keys, different authentication parameters, and the Golden Gate Hub configuration as well. When we're done with each one of the steps, I'm going to walk you through ZDM's response file and how it actually works, how do you set it up, and all the different parameters that are needed for this migration, and also the migration command, what are the different arguments for that command. And then we're going to explain you and show you migration that we run with all of these components in place. So let's first start talking about the source database prerequisites and what you need to have that in place for your migration. Really important, the Oracle source database must be 11.204 or a later release. It must be running in archive lock mode. It must use a server parameter file or SP file. And when they're deployed using Oracle Grid Infrastructure, and have not been registered using SRVCTL, they must be registered before the migration. If the database is 11.2, you must apply the mandatory 11.204 RDBMS patches on the database. You can find more information in the Oracle Zero Downtime Migration documentation. You must see the Oracle support note for Oracle Golden Gate, Oracle RDBMS server recommended patches, and that node in support is identified by the number 1557031.1. It's really important that you see this so that functionality with Golden Gate is guaranteed. You should also enable forced login in order to ensure that all changes that are found in the redo by the Oracle Golden Gate extract will be able to be processed. It is important to enable database minimal supplemental login, to enable the initialization parameter, enable _golden gate _replication, install different packages such as UTL _SPADV or UTL _RPIDV for integrated extract performance analysis, right? And of course, all the other related packages. You need to create a Golden Gate administration user, which is called ggadmin, and will require several permissions. I'm going to go over them in the next slide. So as mentioned before, you will require a Golden Gate user on the source database, in this case called ggadmin. We're creating it with a simple password. This is just for an example. And we're here showing all the grants that are required, all the privileges that are necessary to be granted to that user, right? You can see it here. We also document them in the Oracle ZDM documentation, and we also show it on our step-by-step technical briefs. So you have access to them beyond what we're showing here in this presentation. Now, an important factor to bear in mind is that if the source database were to be a multi-tenant, meaning it has a container database and pluggable databases, then you would also need a user in the container database root as shown below. This user is called c:\ggadmin, as you can see here from the slide, how you would actually spell that. And it's required, right? Because then it is used in the response file under the parameter source container database _ggadmin username. However, in this presentation, the database that we're using is an 11.2 as an example, because we're doing an upgrade between 11.204, moving it to the cloud, and in the process upgrading it to 19c. So you will not require it for this case, but if you were to have multi-tenant database, then this user is required, and you would need to actually add it and create it in the source database. Really important, in case the source is configured with TLS and self-signed database server certificates, please add them to the ZDM server home by executing as per the slide. It's really important, but bear in mind that you don't have to memorize this. We have it properly documented in our documentation and also on the technical briefs that cover the step-by-step migration to the Oracle Cloud. The same thing happens with the wallet that contains the TLS authentication certificates. They should be also stored in the correct location on the Golden Gate hub. Please bear in mind that this is a summary of all the prerequisites that are required for the source database. Please look for more information on our documentation and technical briefs for step-by-step guides for migration. Now, moving forward, let's talk about the database requirements or prerequisites for the target database where you are migrating to the cloud. So when we migrate to the Oracle Cloud, it is important that you create a placeholder, meaning an empty database on the target cloud service before the migration process. And this database must comply with different requirements, proper sizing and the proper version. Now, I know I'm talking about here migrating and upgrading at the same time. So when I say version, you might be asking yourself, well, why does it matter? Well, it matters because the version must be the same, in which case we will not be doing an upgrade, or a higher version would be what it's in this case what we're doing, right? In the example here, we're migrating to a 19c database, but the source is 11.204, so the target is higher. What is not supported is going to a lower version of the database. So ZDM will not do that. But we will help you migrating from a lower to a higher version if that's what you want, or same to same version. A really important prerequisite is the character set. It must be the same in the source and the target database. Regarding the time zone, the target database must be equal or lower in time zone than the source database. And then finally, for SSL and TLS configurations, the same applies as for the source database. The wallet that contains the TLS authentication certificates must be in the correct location in the Golden Gate Hub. You can of course find more information in our docs as for everything that has to do with prerequisites. It's important that we're covering here the basic prerequisites, but there might be other depending on your use case, etc. And we do a really good explanation on them on our documentation. Moving forward, it is really important that you ensure that the wallet status is open and the wallet type is auto login in the target database. If you're migrating to a database that is 12c release 2 or later, and that both the source do not have, the target do not have TD enabled, then it's mandatory that you configure the TD key store before the migration begins, right? And you can, verify this with the following SQL statement. The target database must also have a Golden Gate administration user, ggAdmin, as we created in the source database. But in this case, it's really important. If we're migrating to a non-container database, non-multi-tenant, then you just create the user. If you're migrating to a CDB or container database based architecture, then the user must be created in the PDB or pluggable database. So here with the I provide the example of what specifically how to create this and what privileges need to be granted to this user. But don't worry, we have proper explanation of this and of course the same SQL statements in our documentation and in our step-by-step guide, so you will have access to those as well there. The next step is to connect to the container database or the target database and set the following parameter to true, which is enable _golden_gate_underscore replication, right, to true. And with these SQL parameters here, you can see how that enablement can happen. Now, on the migration, you will require a system, right, on the target database user. For the purpose of this presentation, we're using the system user, but of course it could be different. Just bear that in mind. So in this case, you need to grant the data pump underscore IMP underscore full underscore database privilege to that user. And here I explain how to do it with a specific grant there. But it is required whichever user you're using in the target database as a database user. Now let's talk about the product installation and configuration that is required to run ZDM, Zero Downtime Migration. Okay, here are the installation requirements for ZDM. First of all, ZDM should be running on a Linux host, and this host must be Oracle Linux 7. You cannot use any other distribution. We're really clear in our documentation. But then we don't require a lot of other hardware requirements. It could be a VM virtual machine, or it could be running on a bare metal server. It could be running on the source database server, the target database server. It could be running on a compute node in Oracle Cloud Infrastructure. Important thing is that it doesn't share grid infrastructure home with the server there it is. So basically we recommend to have a separated dedicated virtual machine where you can actually have ZDM running. And this virtual machine should be, of course, in Oracle Linux 7. We require 100 gigabytes of storage just because we generate a lot of logs. And this is important. So for the logging process throughout the migration, we generate a lot of them. And then you can see here some packages that are expected. We explain them in our step-by-step guides and documentation. So don't worry, you can go and check our docs and see specifically which packages should be part of the operating system installation as well. Now, there are several requirements regarding ports that are important for ZDM. So for TCP, we need the port 22 open for SSH. Also TCP, we need ports 1521, 2484, or a database scan listener port, and this will be used for SQLnet. And then for the Golden Gate Hub, we will need for SSL the port 443, and this works for the REST endpoint for Oracle Cloud Infrastructure, specifically for the Golden Gate Hub. Now, as you know, in the side of Oracle Cloud Infrastructure, we have the OPC user, and we will require SSH keys for it. So for the source database server, if the source database is accessed with root, then you don't need to do anything. But if it's accessed through SSH, and it's important that you add the contents of the specific keys, which are explained here. The ID, RSA, pod file, and the authorized keys file. They need to be in the OPC user home on all of the source database servers. And the same applies for the target database, right? And because it's on the cloud and the only access is through SSH, you need to add those keys, same ones, right? On all of the target database servers as well, right? This user, OPC, is a standard for Oracle Cloud, but in order to use the database servers, right? But you can use any privileged user that has pseudo privileges, right? And then you will have to use different ones for the source and target, but this is just an example of how the standard way of working is. Of course, you can change it according to your use case. With all the requirements present, then the first step is to install the Oracle Cloud Infrastructure Command Line Interface, or OCI CLI. And you can do this as you can see here with sudo yum install and then the package name. Then the second step is to create the ZDM group, ZDM user, and the directories that are required. So here we explain how to add that, how to specifically create the directories, etc., and also how to set up the permissions. You can of course also check this information in our documentation and step-by-step guides. Now, as mentioned before, there are certain operating system packages that are required, and you can check them whether they're installed or not by running the following commands. And if they're not, or there's one missing, then you can do a sudo yum install with the specific package name. And then once they're present, and all of them are part of your operating system for the ZDM service node, then you can move on with your installation. Now, with already you're now good to go to download ZDM. The link is here. You can also go directly to the product page, oracle.com/go/ZDM, which will provide a link from you can actually jump to this link here and download the product. Once you have downloaded the product in the Oracle Linux 7 box that is acting as a ZDM server node, you will switch to the ZDM user and unzip the downloaded binaries. Once unzipped, you can execute the ZDM installation script, which is explained here. Of course, you can adapt that to your specific requirements and settings and folders. And once you have actually executed the installation script and it goes successfully, you can actually start ZDM by running ZDM service start, and then checking status by running ZDM service status and see that everything is active and up and successfully installed and ready to go. You will need API keys, so this is a way for you to create them and copy them, which is really important because then they will be used shortly. So please follow these instructions, but they're also available on our documentation and step-by-step guide. So this is just to make a point and show you how we would do it on a production environment when we're actually migrating to the cloud. So with the recently copied keys, API keys, we will now add them to your Oracle Cloud Infrastructure OCI account. So you will go to your Oracle Cloud Infrastructure dashboard and click on your user profile in the top right, select the top option, which is your user, and then in the new window, there's an option that says select API keys and add API keys. You will then paste your public OCI API key that you copied before from the step before and click on add key. And I'll show you in the next slide how would that look. As you can see here, the two screens and how you would actually add the API key. In the next slide, I'll show you exactly when you copy it, how will it look. Once you add the API keys, a configuration file preview will appear that will have information such as user, fingerprint, tenancy, region, and the key file that you need to actually update. So you need to copy this information. It's really important that you copy it and then save it on a text file because we will be using it shortly. Now you have to go back to the console or terminal and as a ZDM user create a configuration file. Just create an empty file with any editor like VI and then paste the config file that you previously copied and put it there, right? Once you paste it, you have to replace the last line that says path to your private key file with this path that I'm providing here, if that's the one you used or the one you selected when you created a key. Now the next step, which is really important, is to create the RSA keys. And you can follow the process on how to do this, following these instructions, we'll move to the next slide, but don't worry, this is all available in the ZDM documentation and the step-by-step guide as I mentioned before. Now as a minimum, you need to edit the etc/host file as a root user on the ZDM service host, adding this information so that it knows how to contact the source to target Golden Gate Hub, right? And it's really important that you edit it with this way. These here are examples, of course, you would have to use your own data. Then the other important step is to add the ZDM host SSH keys both to the source and the target server. This is properly explained in the step-by-step guide and the documentation, so you can look for that step there. Finally, it's really important to configure connectivity between the source server and the target server. You have two options here. One is via scan, so you have to edit the etc host file in both the source and target servers, editing entries for the source priv, source VIP, scan and target scan, and then test it via TNS ping. And we explain this as well in our documentation if there's any further config that you wanna pursue. And the other option is to do SSH connectivity via an SSH tunnel. This requires other adjustments, so I put the link here for our docs, but if you go through our documentation specifically for the connectivity part section, then you'll see how to do this as well. So with ZDM properly installed and configured and all the prereqs having been met, the next step is to configure the Golden Gate Hub, which is going to be deployed in an OCI compute node. Now, before configuring and deploying the Golden Gate Hub, it's important to verify your VCN configuration or your virtual cloud network configuration. So in order to do that, you will go back to your Oracle Cloud Infrastructure account, go to the menu in the upper left and click on networking and then click on virtual cloud networks. You can then see what VCNs are in your compartment, go to the subnet section, then go to the security list section, and then go to ingress rules. Then we have to check if the rules for the specific ports that we are. But if there are not rules for the ports that we need, as presented in this slide, then we need to create them. And I'll explain you how to do that in the next slides to come. So as mentioned, if there is no ingress rules for the ports 443 and 1521, it's just a matter of add the ingress rule using the following instructions and then for each one of the ports. Once you have verified that everything is in place with your virtual cloud network VCN, it's time to set up the Golden Gate image from the OCI marketplace. Basically, in your Oracle Cloud Infrastructure account, you should go to the menu in the upper left, click on it, and then on the search bar, type Marketplace. It will show you the different ones that you just click on all applications. And then there's another search bar where you can enter Golden Gate Migration. There's going to be image called Oracle Golden Gate for Oracle Database Migrations. That's the one you have to click on, accept the terms and conditions, and click on Launch Stack, and then follow all the steps that come, which will be explained here as well. Once you click on the Create Stack or Launch Stack option, the following window will appear. We'll ask information such as the name, which basically is the name for the Golden Gate Hub. You have to select your specific compartment and then follow to the next stage. Now the resources will need name, so display name for the Golden Gate Hub is important, but also really important is the host DNS name, which you will be using later. In this case, we chose OGG ZDM as Oracle Golden Gate ZDM, but you can choose any name that you want to. Then, really important is to select the specific virtual cloud network compartment, the specific VCN that you're using, the subnetwork compartment, and of course the subnet. All of those have to be chosen. Then you have to select your availability domain, the compute shape. In this case, we're using VM Standard 2.4. That's where the actual Golden Gate Hub and the microservices, both the extract and the replicate, will be running. Please select on Assign Public IP and then continue to the next options. You're gonna have two deployments for Golden Gate, one for the source, which you can name source, which we did, and then one for the target, which you can name target. Then you have to select to what type of and version of database are they connecting. So the source is gonna be 11.204 and the target is gonna be 19, because for the purpose of this presentation, we're doing migration in which the source is a lower level than the target, so that you can see how we can migrate and upgrade at the same time. Now remember that you save an SSH key for the OPC user. You need it now, so please copy it and paste it here. Once you're ready, click Next. That will show you one single view of all your entries. So proceed to do a final review, and once you're done and sure of your values, click Create. Upon creation, there's going to be logs of the Golden Gate Hub creation. Go to the bottom of the logs and copy 3 values: OGG image ID, OGG instance ID, and OGG public IP. Please save them on a text file because you're going to need them for later use during the migration. Now, the Oracle Golden Gate Hub has now been installed and the deployment is complete, but you still need to configure it, right? So you need to connect to it and replace the OGG public IP value with the Golden Gate Hub public IP that you copied before, and replace the SSH key name with the one that we used previously. You can do this by following these steps. It is also really important that you copy the output of the command, the cat for the OGG credentials.json file, because you will need it in the following steps as well. Now open a separate browser tab to open the OGG Service Manager. You can do this by going to the HTTPS // and then the OGG public IP value. You just have to replace OGG public IP, of course, with the value that you copied before. These will show you warnings because the page is insecure, because it uses a self-signed certificate. Just ignore them and go ahead. You will use the username and password that you copied from the output from the OGG credentials.json file from the previous slide. So you need to add the username and the password, and then you can click on sign in. Once you're in the Oracle Golden Gate Service Manager, you just have to go to the top left, and there's 3 lines that we call the hamburger menu. Click on it so that you can start working and configuring it. Now, once you click on the hamburger menu, you'll see some options. Click on Administrator, and then this window will show, click on the edit pen that you see on the bottom right to edit the OGG admin user. And what you have to do is just enter the following information, right? The admin for the user, and then of course the password that you want. We use this as an example. Of course you can submit whatever password you feel it's appropriate for your deployment. After you've done the previous step, you will be logged out of the Oracle Golden Gate Service Manager. Please sign in again with the OGG admin user and the recently updated password. In this case, this is the one we use, but put the one you used. In the services table, click on the port of the source administration server, which normally it's 9011, and this will open a new sign-in page. You now should use the username and password from the outcopied OGG credential JSON file from the previous steps. Do not use a newly updated password. Then click on the top left hamburger menu and click on Administrator. Now again, click on the edit pen on the right to edit the OGG admin user. Enter the same information. In our case, we're using the same password to make the process more streamlined, but you can, as you wish, but according to your measures. And once you've reviewed, please click on Submit. Now, this might look like a repeated slide, but it's not. Bear with me. Again, you will be logged out of the Oracle Golden Gate Service Manager. Please sign in again with the OGG admin and the password that you used. But now in the service table, click on the port of the administration server, which is now normally 9021. So you see, it's different, right? Then we'll open a new sign-in page, and again, use the username and password from the OGG credential JSON file. Now, do not enter the newly updated password. It's really important. Now go and click on the left hamburger menu as before, and click on Administrator. Now again, click on the edit pen on the right to edit the OGG admin user. Enter the information as requested admin and then a password of your choice. We again are using the same one to streamline the whole process, and then review that everything is in place and click Submit. This finalizes the Golden Gate Hub installation and configuration process. So now you can close the Golden Gate Service Manager browser windows and move on with your migration process. Now for ZDM to perform the migration, the first step is of course to transfer data to a location in the cloud. So in the case of logical migration, we use the tool called DataPump, and we do an export of dump files from DataPump, and we use the object storage in your tenancy to transfer those files. So I'm gonna show you now how to configure that object storage bucket in Oracle Cloud Infrastructure in your tenancy. Now go back to your Oracle Cloud Infrastructure dashboard, select the hamburger menu on the left, top left, click on Storage, and then click on Buckets. Now click on that Create Bucket option. This will show you the Create Bucket pane or window. Just select the bucket name. In this case, we use ZDM bucket. The default storage tier should be standard. Then select encrypt using Oracle managed keys. And other than these three fields, you can leave the rest blank and then click on Create. Once created, a details page will come up. And then there's two important pieces of information there. One is the bucket name and the other one is the namespace. Please copy both of them and save them for later, because you will need them for the migration process. Now let's talk on how the authentication token is to be created and configured. Now to create an authentication token, go to your OCI or Oracle Cloud Infrastructure profile, select the icon in the top right and click the username. Now on the bottom left, you will see different options. Specifically on the resources, select the one that says auth tokens, which is for authentication tokens, and then click on the generate token option. Now a generate token window will appear. You can enter a description for the token and then click on generate token. it is really important that you, once it's displayed, you write it down and copy it and save it, because you cannot access again this token. If you lose it, you will need to generate a new one. Now, with all the different components in place, we can go back to the ZDM server node. And the only thing missing now is to configure the response file, which will have information from your source database, target database, backup, etc., migration methodologies, and so on. So I'm going to show you step by step what response file parameters are required specifically for this migration. Of course, ZDM has multiple response file parameters depending on each one of your use cases. So the best practice is to always look into your documentation and see whether there is a specific response file parameters that are specific for your use case. So let's start with the first parameters. First, the migration type, which there are several of them: online logical, online physical, etc. In this case, we will use online logical as a parameter, which leverages data pump and Golden Gate. The data transfer medium, it's in this case the backup location. We say OSS because it's the object storage service that we're using here. The target database OCI ID specifies the connection details for the Oracle database. Then we have the target database username, which specifies the target database admin username, and the source database admin username, which specifies the source database administration username. Next slide will show you an example of how this will look in your response file. Of course, bear in mind this is just an example, but this is how it should look. And of course, adapt it to your specific parameters and specific use case and environment. Next, we have the source database connection detail host, which basically specifies the listener for the hostname or IP address. In case we're migrating to a non-autonomous target, the source database connection details port for listener port number for the source database, again for non-autonomous targets. The connection detail service name for the source database, again the fully qualified service name. And for target database, we have the same connection details for the host, which is hostname or IP address, and then connection details port for the target database, which specifies the port number of the listener in the target database. This is then an example of how it would look, but of course you would have to adapt this to your own parameters in your own environment. Now we move on to the next set of parameters. First, for the target database, the connection detail service name, which specifies the fully qualified service name. We also, for OCI authentication details, we have for the user principal tenant ID, which specifies the OCI ID of the OCI tenancy, the user principal user ID, which specifies the OCI ID of the IAM user, the user principal fingerprint, which of course specifies the fingerprint of the public API key, and the user principal private key file, which specifies the actual path, absolute path of the API private key file. For the previous parameters, these are an example of how the values would look in the response file. Please bear in mind that these are sample values, they're not real values. And then when you are creating your response file, you'll have to use your specific data according to your environment and parameters and configuration. Moving on, we have the OCI authentication details region ID, which basically specifies what's the OCI region, and so ZDM knows where it's migrating to. The source database ggAdmin username that you created, which is the Golden Gate administration username, the target database ggAdmin username, the Golden Gate hub admin username, and the Golden Hub URL, which is basically that URL is the hub's REST endpoint. Again, here's an example of how the previous parameters from the response file would look, but then again, these would change depending on your environment and your specific variables. But this is how they would look for our migration, for instance. Now we also have the Golden Gate Hub source deployment name, which specifies which of the microservices is going to operate on the source database, and then the Golden Gate Hub target deployment name, which specifies which of the Golden Gate microservices is going to work on the target database. Then the compute ID for the Golden Gate Hub, which basically is the cloud identifier for the G Hub, the data pump set in job mode, which basically it's telling ZDM which type of data pump export mode is going to be operating. In this case, we use a schema mode. And then we have the include objects -n. In this case, we have only one, which basically specifies the database objects to include in the migration. This integer must replace the n value. So basically, you can have include objects -1, include objects -2, etc., and add them as required. In this case, we have one because there's only one that we're using for one schema. So again, this is a great example of how these look. Remember when we created the Golden Gate Hub deployments, the one for the source database was named source, so we have it here. The one for the target was named target again, and then the rest of the values. These of course will change depending on your configurations in your environment. We then have more values for data pump settings. So as data pump parameters, we have import parallelism degree, which specifies the maximum number of worker processes that the data pump job is using. Then we have the same for export parallelism degree, which specifies the number of data pump processes, but for the export side, right? So we have one for the import and one for the export. Then we have the data bucket namespace, which is when we were creating the objects or bucket, I told you that you have to copy that namespace and also the bucket name. Finally, we have the export directory object name, which is basically specifies the directory name on the source server to store the data pump export files that then ZDM will create, will move to the object store. If it doesn't exist, ZDM will create the object. So for the previous parameters, this is an example of how they would look. We set up the parallelism degree in 2 for both the import and the export, then the namespace and the bucket name that we're using, and of course the directory for the export directory object for data pump. We then have the export directory object path, which is the actual directory path where in the source server the data pump export files are going to be stored. Then we have the import directory object name, which is the path on the target server to store the data pump export dump files. And then we have the create auth token. Basically specifies if the token is needed to be created for the specific OCI user to import the data dump files from the object store into the autonomous database. For migrating into DBCS or SSCS, that parameter is false. And with this, we finalize the different response files parameters that you're going to need. This is how these would look for the last 3 parameters, but then we're ready now to evaluate the migration command. So I'll talk you through how it works and then perform the actual migration. So now let's go and see how the migration would work. First, evaluating the migration command, seeing each one of the parameters, and then actually executing it. So ZDM is a command line interface based product, and the command line interface is ZDM CLI. There's many options. One of them, many commands, one of them is migrate database, but there's many, right? For migration of the database, there's many parameters and arguments for this command. We're going to focus on the ones that are here, which will help us with this migration specifically. But please review our documentation and review our step-by-step guides so you can get more information of different arguments and different parameters for the commands, so that way you can see which one will work better for your use case and whether you will need further information, etc. So let's see each one of the arguments that are part of the migrate database command. First, we start with source DB, which is the name of the source database, source node, which is the host where the source database is running. Then the authentication plugin, we use ZDM Auth. You can read more about how this works on documentation, and it has 3 arguments: source RG1, source RG2, and source RG3. We are seeing here in this slide 2 of them. We'll check the next one on the slides to come. Source RG1 is the user, which is the source database server login username. Source RG2 is the identity file, which basically is where the private keys for ZDM, the user, are located. So basically it's a path for those keys. Then source RG3 is the pseudo location for the source. Then we have the target node, which is the server name for the target database where it resides. Then we have TGT auth, which is the authentication plugin for the target. We use ZDM auth, and again, you can check more on the documentation how it works, which has also 3 arguments: TGT auth 1, 2, and 3. Number 1 is the user, which is the target database server login username. 2, again, the ZDM installed user private key file location, and 3, the pseudo location for the target. So once you issue the command for migration and you're ready, what ZDM will do is actually request information for different passwords and authentication. You will provide those in the command line interface, and then ZDM will provide a job ID. So as you can see here, it says operation scheduled with job ID. In this case, it's 24, but the first time you issue a migration command, it'll say number 1, and then we'll continue growing there. Then you can query that command, and I'll show you how in the next slide. So as I mentioned, once you issue the migration command, ZDM generates a job ID for the migration work, and then these will run in the background. So ZDM is great because then you can actually issue more migration commands for different databases and have multiple migrations in parallel. But in this case, we're just doing one, and what you do is you can, there's a command called query job. So ZDM CLI query job. The argument is job ID, and then you put the ID number, and that way you can see how the migration is progressing. So if you were to query the migration in the middle of it, this is actually how it would look. In this case, the migration has progressed from the previous and basic steps of validation all the way to actually monitoring the Golden Gate lag and doing the switch over. So in this moment, actually ZDM is switching over the source database, so application from the source to the actual target in the cloud. I'm gonna present to you another query output once the migration has finalized, and then explain how it actually worked under the covers and what ZDM did. So this following query of the job shows that it succeeded and actually has finalized the migration with all the different phases that imply online logical migration using data pump and using Golden Gate. What I'm going to do now is in the next slide is go through each one of the steps on a, of course, general overview way, so you see what ZDM actually did and how it actually works for logical online migration. So here are the basic steps for ZDM logical online migration, which we did today, right? First, we download and configure ZDM. Of course, we went through the source database prerequisites, the target database prerequisites, all different connectivity, etc. configuration, then authentication, then backup location for the object store, then Golden Hub configuration. But once all of that is in place and you have downloaded and configured ZDM, you issue the migration command as you saw with the specific response file parameters, etc. and ZDM will start the database migration. ZDM connects to the source database, connects to the target, and has the source connect to the backup location, right? Then ZDM will configure the Golden Gate microservice to start capturing transactions. So we have now an extract where we're capturing transactions from the source database. ZDM will then instruct data pump to do an export job from the source database to the backup location. Then ZDM will instruct the target to do an import job for the data pump dump files from the backup location to the target. If the target is an autonomous database, this is completely automatic. If the target is XACS or DBCS, for instance, then what ZDM does is it copies the data pump dump files from the backup location in the object store to a local file system in the target, and then instructs the target to do an import job. But of course, all of this is still automated by ZDM. Then ZDM configures Golden Gate microservice on the Golden Gate Hub, which in this case is the replicate, and starts applying changes to the target database. So it's sure that it's synchronized. There's a proper synchronization between the source database on premises and the target database in the cloud. One is all synchronized. ZDM switches over and finalizes the migration process. And all happened, as you saw, on a step-by-step fashion, fully automated by ZDM. In order to get there, of course, there's preparation that needs to take place, and I walked you through today how this is done and how you can achieve it. As you can see, it's great. The product and the tool allows for you to migrate a database and have all of these orchestrated and automated for you. Now, before ending our presentation today, please let me share some resources with you. First, our product page, www.oracle.com/go-to/ZDM. Then we have a physical migration step-by-step guide, a logical migration step-by-step guide, and our documentation. You can find all of these in our main product page, so you don't have to worry about copying all the links or URLs here. Just remember the product page, www.oracle.com/go-to/ZDM. It's been a pleasure for me to be here with you today. Please visit us at our product website. If you have any questions or anything that you want to know more about cloud migration at Oracle, you can also follow my Twitter account, which is @productmanaged. It's really, really great to be here in this conference. It's amazing to be part of this community. Thank you so much for taking the time to learn about ZDM and how to migrate and upgrade your database to the cloud at the same time.
CloudDB, shaping your new normal.